All connective tissues, regardless of the type, share three main structural elements: ground substance, fibers, and cells. These components work together to form the extracellular matrix, which gives connective tissue its strength, elasticity, and resilience. Ground substance is the unstructured material that fills the space between cells and surrounds the fibers. Think of it as the background gel of connective tissue. It's composed of interstitial fluid, which allows for nutrient and waste exchange. Cell adhesion proteins like fibronectin and laminin, which also act like glue to anchor cells in place. And proteoglycans, which are proteins with long sugar chains called glycosaminoglycans, or GAGs. These molecules hold on to water, giving tissues their resistance to compression. Chondroitin sulfate and hyaluronic acid are good examples that show up in cartilage and joint supplements. Fibers provide the tensile strength and structural support for connective tissue. There are three types: collagen fibers, elastic fibers, and reticular fibers. Collagen fibers are thick and strong and give tissues the ability to withstand stretching. These are especially prominent in tendons and ligaments. Elastic fibers are thinner and made of elastin, allowing tissues like skin, lungs, and arteries to stretch and recoil. Reticular fibers are the most delicate and form fine branching networks that support soft organs like lymph nodes and the spleen. You'll often find reticular fibers at the boundary between connective and epithelial tissues. Connective tissue cells come in immature and mature forms. Immature cells, called blasts, like fibroblasts, chondroblasts, and osteoblasts, are actively dividing and secreting the components of the extracellular matrix. Once they mature into cytes, like chondrocytes or osteocytes, they shift to a maintenance role, keeping the tissue healthy and repairing it when needed. Blood is a special case, where hematopoietic stem cells give rise to the cellular components of blood, but don't themselves form the plasma matrix. Importantly, mature cells can often reactivate and become more blast-like again during healing. Adipocytes are specialized connective tissue cells that store energy as fat. White fat cells are like energy storage units. They hold large droplets of triglycerides, cushion organs, and help insulate the body. Brown fat cells, in contrast, are metabolically active and rich in mitochondria. They burn fat to produce heat, a process known as thermogenesis. This is especially important in newborns and in cold climates. Beige fat is a third type that can be recruited to behave more like brown fat under certain conditions, such as cold exposure and certain hormones. White blood cells, or leukocytes, are another important population found in connective tissue, especially when the tissue is inflamed or injured. Granulocytes like neutrophils, eosinophils, and basophils are part of the first line of defense. Neutrophils phagocytize bacteria, eosinophils handle parasites, and basophils release histamine. Agranulocytes include lymphocytes, which produce antibodies and kill infected cells, and monocytes, which can become macrophages. These immune cells patrol connective tissues, responding to pathogens and cleaning up debris. Mast cells and macrophages are resident immune cells that live in connective tissue even in the absence of infection. Mast cells are loaded with histamine and other inflammatory chemicals and are central to allergic reactions. They also play a key role in tissue repair. Macrophages are large phagocytic cells that consume dead cells and pathogens. They're essential for tissue maintenance and immune surveillance. In wounds, they clean up damaged tissue and orchestrate the healing response. The diagram here shows their placement alongside fibroblasts, fat cells, capillaries, and fibers, highlighting the complex interactive nature of connective tissue.